All right, I think we're all here, except for the few people whose legs I see there. My name is Bart. If you want to find me, my name is Bart Feenstra on Twitter. I'm Xano on Drupal.org. And we're going to talk about the plugin system in Drupal 8, which is one of the new subsystems in our new and favorite version of Drupal. It solves a lot of our problems. If you're a backend developer, you will most likely have to work with this system. We're going to run through why. We're going to run through how it replaces things from Drupal 7, what you can do with it. There are contributed modules that can improve the core system. So short slots, so no live demo, but if you would like a bit more explanation about it afterwards, I will be at the code sprints until when they end. I'm leaving on Monday, so I'll be here tomorrow. Just find me at the code sprint room. If you have any questions, just let me know. I'll try to help you out. Of course, what are we talking about in the first place? Plugins are basically a way that Drupal provides us with to swap out particular functionality. They're generally very small. They perform a small task or a few small tasks. And the idea is that any plugin of a type can be swapped for another plugin from the same type. For instance, a block, they all work the same. They do a different thing internally, but one block can be replaced by another block, and the system outside doesn't really care. The only thing is you get a different result. That's why they're swappable. And they're dynamically discoverable. You build them, you put them in the system, and the system, which is Drupal, will automatically find these plugins for you and allow the rest of the site to use them. Another really useful thing is that plugins are uniquely identifiable. That helps with the swappability. If you have multiple plugins of the same type, like blocks, but with all, they all have their own ID. Given a plugin, you can read its ID, and given an ID, you can find the right plugin that goes with it. They can have metadata associated with them. They can tell the system about their human readable title or label. They can give a description. And depending on the plugin type, they can have all kinds of static metadata associated with them that define how they work, that define how any instance of that plugin works. And as we just heard, there are multiple instances of the same plugin. We just saw or heard blocks are plugins. That means we can have multiple instances of the same block. Unlike we did in Drupal 7, where one block was only usable once for every theme, we can now do all kinds of crazy things with it. Like the same block can be used multiple times with different internal configuration, because one plugin can be instantiated multiple times. And that's also one of the big differences between plugins and services in our container. So to explain why we have the plugin system in Drupal 8, we have to go back in time a little bit, about 5 years to Drupal 7. And because that's how long the Drupal 8 development cycle took. And we had plugin functionality in Drupal 7, but they worked in many, many different ways. So the most popular or the most common method of discovering pluggable functionality was through hooks. We used hooks for all kinds of things, for events, for discovery, for altering data. They were a method, but not for the same goal. We used them for different goals. And discovery of pluggable functionality was one of them, like hook field info, hook field widget info, hook block info. They're all basically what we call plugins in Drupal 8. But they were implemented using hooks in Drupal 7. There were different methods for file-based discovery. Basically, we find, like a hook basically has a predictable name depending on the module it's for. So you just fire the hook and the hook exposes one or multiple plugins. File-based discovery checks a folder and scans that folder for plugins that are located inside of it. CTools was one of the more popular examples of providing a discovery method that did that. We had magic hooks and callbacks, magic include files. And once you understand how those work, they're really nice because it works out of the box. But to try and understand how all these different things work, because they're magic, they're not explicitly documented or explicitly coded like that, it's rather difficult to discover how this works, to find it out, and debug it. A lot of plugins, like we saw just now, use magic callbacks and everything, but only a few of them, like the ones that were based on CTools and views, for instance, they were classed. And the advantage of having a single class as a plugin is that all of the plugin functionality is in one place. You don't have different functions throughout, like a module file or an include file. You have them all in the same class. That means that if you move the class, you move the entire plugin. if you move that class, you are sure that you didn't leave some plugin functionality elsewhere in another function. If you want to remove it, you just remove the class. It's clean, it's clear. It's confusing. Yeah? It takes a long time to explain to someone. It's not consistent. You need to learn different systems to work with all of these things. So in Drupal 8, we introduced the plugin system, originally based on the CTools plugin system, and done completely differently to make it work a lot better and nicer. My background image failed to work. So one of the main advantages is that any plugin in Drupal 8 is always an instance of a class. So everything that the plugin does is on that class. Like we just said, that's good because you keep things together. We'll see how that works even better with the metadata. Interfaces are a PHP thing. They, for those who don't know them yet, a class provides functionality that functions with the bodies, like classes actually do something. An interface is like a blueprint for a class. It defines maybe constants, it defines function signatures, so it defines a function and the parameters and the output, but it doesn't actually provide a function body. You can't instantiate an interface into an object, you can't call the method. It just says that if a class implements this interface, it needs to provide these methods that work this way, that have this input and output, but how these functions work internally, these methods, is up to the class. So we have a block plugin interface that says like, oh, every block plugin provides these methods. How it does it internally, we don't really care. We don't mind if it renders a login form or a search form or a powered by Drupal message. That's fine with us, as long as we can tell the block to render itself to us. And it has a consistent API. In Drupal 7, we had all these different methods, and in Drupal 8, there is one consistent API for handling any plugin type. Yeah? So we have blocks, we have image formatters, styles, input formats, all the field plugins. They're all plugins. And conceptually, they all work the same. The way that they are discovered, the way that they are defined in the system, the way that you instantiate them as a user of someone else's plugin. So you have to learn one system, and then you know everything. No more dark magic. No more, yeah, I understand that you thought it works like this, but it doesn't. No, it's clear. It's all in the code. It's right there. You can't deviate from it. You can't say like, oh, I want to use this block plugin interface, but do it differently. You can't, because you get a syntax error. Before we go further, there are a couple of names and phrases that we need to go through. It's confusing enough as it is. So the first thing that you have to know is a plugin type. A plugin type doesn't really do anything. It's a concept, like a block or an image style. There are different plugins for that type. But basically, every plugin type has an interface that any plugin needs to implement. The pieces are starting to come together now. And then you have a plugin for a particular type. If you define a block, you define a plugin. And a plugin is, in its smallest form, only the definition of that plugin. It's only the metadata of that plugin. And the two required bits in this metadata, in this plugin definition, are the plugin ID, so you can identify the plugin, and the class, so you can instantiate it. Those are the two minimum requirements. You don't even need a human readable label. You don't need all the extra metadata that field widget plugins expose which field types they can be used with. That's not a requirement of the plugin API. That's a requirement of the field widget plugin type. But the plugin API, in a definition, only requires the ID and the class. That also means that you don't need the class itself. Like, the most important thing you need is just these two little bits to call the plugin definition. And you discover the plugin definitions. That's what we call plugin discovery. There are a couple of methods to do that we use in Drupal core, and I will show them a little later. So you come up with a plugin type, and then you figure out, okay, we have this concept, and then we need to make sure that people can build their plugins and that we discover the plugins that they write. And after you've discovered these plugins, you need to instantiate them. That's what we use plugin factories for. We found the definitions, and then we want to get an instance of that class. We use plugin factories. And we combine the discovery and factories, in most cases, into what we call a plugin manager. The minimum thing they do is discovery and factory, but they usually also have a few extra methods for additional functionality, depending on the plugin type. So every plugin type, in most cases, has their own plugin manager class. There are services on the global service container. So there's always one instance of that plugin manager in the whole system. You can reuse it, like different classes needed. They all get the same instance. So you built your plugin. You discovered it. Then it runs through the factory to create an instance. And then you have your instance. And then that's really just an object instance in PHP of that plugin class. And that's what you can work with. It gets the definition injected, like the metadata, but it also receives plugin configuration. And the definition is the same for every instance of a particular plugin. If you have the powered by Drupal block, you'll get a little message that you see at the bottom of the page in a default Drupal install. The definition is always the same. If you create multiple blocks, multiple instances, the definition with the plugin ID and the class name and a few other things, they're always the same for all these object instances, but the configuration can be different for every single object instance. It is basically their internal state. And the reason this is a different thing, this is not actual object state. We don't store these in different properties. We store them in what we call the configuration, is because we can import and export it. If you have a plugin instance, you can ask it, give me all your configuration, give me your ID. You can do fun things with it later. And then when you create a new instance, you can be like, oh, hey, I want to create an instance of this plugin with this ID, and here's the configuration that it needs to receive on top of its plugin definition. And using that approach, you can store a plugin instance on file, for instance, by storing its ID and its configuration on file in a config YAML file, for instance. And you can recreate it later. So if you configure a plugin instance on an admin page, you can store its configuration, and then when a user needs it later, like they perform a request to a certain page that requires that plugin instance, the code can read the configuration from the file, create a new instance that works the same as the one you configured on the admin page before. We do this, for instance, with blocks, with field types. Like the default values for field types, for instance, are part of the field type plugin. And we store that in the field config storage, or field storage config entity on file in YAML. And then when you load an entity of that type, or you create an entity of that type, it loads the default values, and then it uses all that information to set the default value for that field on that entity. And there are many more applications that you can use this process for, this approach. So we said there were multiple discovery methods. We don't use space shuttles for them, but that would be cool. The first one, and the one that you will see most of all, is what we call an annotated class. And an annotation, you probably know, you've probably seen them before, even if you don't know the name. If you write a function and you have a documentation block and you write at param or at return, that's an annotation. So all these keywords in a doc block that start with an at sign, like in an email address, those are annotations. And those are basically tags or markers in the documentation blog so that a machine parser can find them and then read the rest of it. So if you have at param, you have a data type and an argument name. It parses the data type and the argument name. But it finds the whole thing using at param. And we use similar annotations, but our own ones, to find plugins. We'll see an example in a bit. The good thing about that is that you have the doc block with the class at the same time. But sometimes we don't want to have to write a new class for every single plugin that we write. For instance, our menu links in Drupal core, they basically all use the same class, but their definitions are different. Yeah? So when we instantiate these menu links, they receive their definition in their plugin class. So using the same class, but with a different definition, they can decide to behave differently. And that's what they do. We use the same class, but depending on the definition, which contains like the path they are for, or the route, their title, they render themselves as different links with a different title and a different URL that they point to. The useful part of this is that we don't have to write empty classes. You know, with a doc block and a class under it, it's useless if the class is empty. It's too much work. So we put the definitions in YAML files, and we remove the overhead of writing classes. There's static discovery. There's a class called static discovery. We usually use it for testing. We literally, in code, in PHP, inject, we tell it like set definition. We hard code static definitions in it. It's very lightweight, useful for testing because we don't have any file interactions. We don't scan the file system for plugins. It's just there. You won't really use it for anything else than testing. And there's the last one is hook discovery. It's a compatibility layer when we still had hooks, but we wanted to use plugin managers. We used the hook discovery to connect hooks with plugin definitions to the new plugin manager system. We don't use it, and it's still there because we technically cannot remove it because of backwards compatibility breaks, but we don't actually use it anymore, and nobody here should use it. It's still there, and you know why not to touch it. So this is what an annotated class looks like. And this is an actual example from the REST module. As you can see, there's the plugin ID. And this is the plugin definition. You see here at views display. This is the actual annotation. And then it contains sort of an array of key values. And this is just a file called rest-export.php in the right location with a class, because it has contents. It has logic. So this means that plugins of this type generally provide their own logic. They're different from each other. But you see there's no class key in this definition. And that's because when we use annotated class discovery, we find the class, we find the doc block that belongs to that class, and we just set the class name in the definition ourselves in the discovery class. You don't have to do that, as the class does it for you automatically. So that's why it's not there. And then all these other keys, except for ID, those are specific to the plugin type. Yeah? Only the ID key is part of the plugin's API, the system, and the rest is specific to views display plugins. The plugin is provided by the REST module, but it is a views display plugin. This is what YAML discovery looks like. As you can see, there's no classes here. There's no class key here, because this is an example of menu links where we merge in the default class. It's easy. It's a very fast way of defining new menu links. This approach is used by the menu links and local tasks and actions and several other plugin types. If you write a custom contributed module that introduces a new plugin type, you can decide, OK, we generally want to reuse the same class, so we use the YAML discovery. One very awesome and kind of tricky new introduction in Drupal 8 is that plugins are the first thing that actually provide embeddable forms to configure themselves. We never really had that in Drupal 7 and before. There were always hacky little methods. This is the first. There's a plugin form interface that provides build, validate, and submit configuration form methods that can be embedded into a parent form. And the reason why they're embeddable is because the parent form has a getFormID method. If you have a form, it needs to have an ID. These don't provide an ID, so they are embeddable. They must be used in a parent form, and they cannot technically be used on their own. And it's great. So if they have configuration that can be imported and exported, and they implement their own little form, you can display their configuration form in a parent form. In their submit method, they store the submitted form values inside their own configuration. And then the parent form can ask, like, OK, plugin, give me your configuration, and I can store it on file. With the example of the field type default values, happens exactly like this. So what we just saw with these discovery methods is that you have to write a new definition for every plugin that you write. If we go back to blocks, blocks are cool. We have the Powered by Drupal block, we have the login form block, we have the search menu form block, and we have blocks for every menu in the system. But we can create menus on the fly. Yeah? You go to the admin interface, you create a new menu, you remove a menu. So the block, and we need a block for every menu, but we don't know how many menus we have. Yeah? They are dynamic. But still, we have to have all these plugin definitions for them. And that's what derivatives come in. If you define a derivative or a deriver for a plugin, then what happens is that the plugin's definition itself is not used directly, but the system creates an instance of the deriver class, gives it the base plugin definition, and then the deriver returns 0 or more new definitions for that plugin that replace the old hard-coded in YAML or the annotated class definition. So we have a system menu block plugin. And then if you have no menus, the deriver class returns an empty array, no definitions, because there are no menus, so you don't need any blocks for them. If there's one menu, it returns an array with one definition. If there are 5 menus, the array contains 5 definitions. And from that point on, it works the same as everywhere else, because we don't really care about how it's defined in the system. We care about the definitions, right? And we have them. We have these definitions with their own IDs. We don't have time for a demo, probably. But again, if you want to see this in action, ask me at one of the sprints today or tomorrow. I can show you. Or if we have maybe a bit of time left after this, come here. It's a bit of an abstract way of thinking. But you're basically replacing the one original definition with 0 or more other ones. And a class like that, I have no example, can be very simple. Like the system menu block basically gets the menu storage, like which menus do we have? For every menu, create a new definition. It's like 10 lines of code. As with a lot of things in Drupal, the core APIs are awesome. Yeah, they do amazing things. They let us, we unified all of our discovery, like swappable functionality discovery stuff We work with one API, like the entity API in Drupal 7, but it's not complete. It's there, it does an awesome job, but it can always do more. It can always provide you with better tools. So we wrote the plugin module, like the entity module in Drupal 7, which improves the entity API in core. The plugin module in Drupal 8 improves the plugin system in core. A couple of the things that it does that core doesn't do is the discovery of plugin types. If you only use the core system, you need to know that a certain type of plugin exists. You need to get the plugin manager service from the container. And once you've done that, everything works the same for every plugin type. But you need to know about the plugin type and the service ID of the plugin manager beforehand. If you don't know that information, you can't do anything. So the plugin module lets modules define their plugin types so they're also discoverable. If you write a plugin type.yaml file prefixed with your module name, and you put content like this in there. So this is an example from the plugin module itself. It provides a plugin selector plugin type. The label, and here we see that we give the system the ID of the plugin manager service so that we know, like, oh, I want to work with plugin selector plugins. Give me the plugin manager. It can automatically get the right service from the container. This one is interesting because plugin definitions are arrays. Arrays are cool. Arrays are fantastic as long as they only contain list information. If every item in the array is conceptually of the same type as any other item in the array, like you have a list of phone numbers or you have a list of user objects. The moment you start using your array keys for different types of values, like you have a label array key with a string, and you have, for a field widget, supported field types array, then one array item is a string, the other is an array of strings. That becomes difficult to work with if you don't know the exact contents. It's no longer an actual list. And every single time you work with that array, every time you accept it as an @param or an @return, you have to document the entire array again if you want to be clear to your people, like the developers using your code, what the array contains. So ideally, this should be objects. Yeah, because an object, so like, okay, you just have an instance of plugin definition, the class, and it contains these properties. So you just tell everybody, oh, what you get or what you have to pass on is a plugin definition object. And then people go to that object and they see exactly what the data is that it contains, what they can do with it. And because these plugin definitions in core are not all the same, like most of them have a label key for the human readable label, but blocks have an admin label key. If you want to write code that works with any plugin type in the system, that doesn't help you, because then you suddenly have to build all kinds of workarounds. Sometimes there's a label key, sometimes there's an admin label key, sometimes there's a title key. That's stupid. It will go wrong very easily. So we decorate it in an object, and that's what the last key is for. Classes like these can be instantiated and given an array plugin definition, and they provide methods according an interface that code can work with. They can look, oh, give me the label, get label. And then the plugin definition decorator for the blocks reads the admin label key. For most other plugins, it will read the label key. So to the outside world, it looks like an object with methods you can call. It's very predictable. Now, this is a little boring. The module also provides an overview of the different plugin types in your system and the different plugins for all those plugin types. It's kind of like the field list overview in the admin status report, but a little more bigger, and then for plugins. It's useful to get an idea of which plugins are there in my system. How many plugins does Drupal use and provide? Basically, how pluggable and how swappable is Drupal? How much can I do with Drupal without actually hacking any of the code? We saw that plugins can export their configuration, or like you can ask the plugin instance for its configuration to store it for later use. But if you store it in YAML files, configuration files, they need schemas to describe the structure of the configuration, to say, oh, these configuration properties are translatable. We use schema files for that. And if you write code that has to work with any plugin of any plugin type, you have to have a very predictable way of finding out what the schema is of that particular plugin you're working with, of the particular plugin that you are storing the data for. There is no convention. So the plugin module introduces this convention. If you write a config schema, prefix it like this: plugin.plugin configuration dot the ID of the plugin type, like plugin_selector or block, another period, and then the actual ID of the plugin. If you do it like this, the plugin module can automatically scan the system view and find the right schema. If you don't want to change your existing schema IDs, or if you like, I think it's ugly, you can do this in your plugin type definition and say like, okay, I have a custom schema ID. Here it is. You can just read it from there. So what happens is, I'll show you an example in a little bit, but that basically means that given any plugin, you can store its information safely, it's translatable, it works. This is what we just saw. Plugin definitions are arrays. Bad for a number of reasons. There's a plugin definition interface in core that does a basic little bit of making it into an object. The plugin module, as we saw, provides these decorators. They implement this interface. They provide a lot more methods. We're trying to expand it in core over time. It's probably going to take until Drupal 9 to be fully completed. But this is something that's not entirely new by the plugin API. It's in core, and we build on top of it. Most of the time, though, if you work with block plugins or field plugins and you ask their plugin managers, you'll get the array back. It is only relevant when you write code for different plugin types to use this approach. So these are plugin selectors. In many cases, you will want site administrators to configure your site, to say like, oh, to do this action, to perform this action, the site administrator tells the system like, okay, to do this, you need this plugin. But because plugins provide their own configuration and their own configuration forms, at that point, you'll want, if you select the plugin to use, you'll want the plugin's form to show up in your admin panel so you can configure it and then it can be stored. That's a lot of form handling. Selecting the right plugin, displaying its configuration form, also like keeping the values. If someone switches back and forth between different plugin types and is trying to find the right one, or between different plugins, not types, and tries to find the right one, like do I need this plugin or do I need that plugin? In most cases, if you don't write the code for it, you select another plugin, you get a new form of that same plugin that you just played around with a minute ago, but it's empty. The values that you entered before are no longer there. Plugin selectors solve this for you. They keep all the information until the form is stored. It's very user-friendly. You can have different selectors like radio buttons, drop-down select lists. You can write your own selectors using very complex user interface elements. The essence is the same. They allow you to select and configure a plugin. Plugin selectors are plugin themselves. So there are actual use cases of a plugin selector allowing a site administrator to select and configure a plugin selector for somewhere else. Like the payment module, for instance, lets you do that. Like, what is the default payment method? Oh, what is the, like for a payment form, how should people select their payment method? Should they use a drop-down select list or a radio? So the admin page uses a plugin selector with which administrators can select the plugin selector that the customer needs to use and configure how it works and is displayed. It's 500 to 1,000 lines of form API code. It's worth looking at it if you need to build admin interfaces like this. Saves you a lot of trouble, and with about 5 to 10 lines of code, you get a highly user-friendly piece of interface for your admin pages. This is where we get back to the code you write that needs to deal with plugins of all kinds of different types. The plugin module contains a field type that you can attach to content entities that can actually store a plugin instance on that content entity. Theoretically, you can use it to store a block on a content entity, on a node. You can go really, really crazy. There's no use case for blocks as far as I know, but there was no reason to prevent it because the code was written to work with any plugin type. So the field type, as we saw earlier, has a default value, right? But because the field type can store any plugin of any type, it needs to be all abstracted out. So it can't use these array plugin definitions directly, so it uses these object definitions, the plugin definition interface version. Because the definitions in most cases are arrays, we use the decorators, as we saw in the plugin types YAML file. It wraps them in there, and then it can talk to the same methods, and it makes sure, it's sure that it will not break. To store the default values, it uses these configuration schema IDs to reference the right schema for the selected plugin in the configuration YAML file of the field that you create on the content entity. The widgets are the plugin selectors, as we saw before. It's a little bit of glue code, about 100 lines, and all the plugin selectors are suddenly available as field widgets. So if you have a block field on a node, you can select, oh, I want the select list or the radios as the widget for that field. And then when someone creates a new node, they can use that plugin selector to select the right block that they want to display, when they select the block that they want to attach to that node, its configuration form shows up. You can configure it. It is stored. And then the block ID and its configuration is stored in the database along with the content entity, with the node. When it's loaded again next time, you ask the field, like, give me the plugin instance that you have, and you get a fully configured block object that works exactly like you configured when you created the entity. Blocks are a bit of a stretch in this case. You will most likely not use it, but we use it in the payment module because a payment method on a payment is a plugin on a content entity. You configure the payment, like, oh, it's but for this price, it's like I want to use this bank. This is when the transaction was completed or something. You wouldn't store credit card information in it, but there are all kinds of other things that you can store in it. The payment statuses, payment line items, they're all plugins stored on the content entity. There are a few basic formatters. They're not entirely useful because plugins are not meant to be rendered. They're meant to be used. But this is basically what it provides. We have 10 more minutes.
Yes, sir.
There was a thing. Oh, I can show you the derivers very quickly, how that works roughly, so you have an idea, because it's one of the more abstract things in Drupal. Let me quickly load my editor. Oh, this is full screen. That doesn't work. So this is Drupal 8. This is 8.2 actually. I'm working on subforms. So as we saw, plugin form configuration forms are basically subforms, but they get the global form state. So they can collide with the parent form. Like if they look up their values in the root of the form state, they can collide with the parent form because that also works at the top of form state. We're working on a solution to make sure that the subform can never read or overwrite the values of the parent form, and it always assumes that it itself is the parent. It itself is the root. It solves a lot of problems and documentation issues. So if we go to the system, oh, that's the wrong shortcut. System menu block, we can see there are two classes called that way, but because they're in a different namespace, like this is the actual plugin and this is the derivative, we already see what's going on. So, yes, a bit more space now. Can we make this smaller? Yeah, so we see here the definition of the system menu block. This is the block that turns every menu in, the block plugin that turns every menu into a block in the system. And the very last line here is the deriver, and it defines or it references another class, which is the deriver, which turns this definition, this little annotation here, which replaces this one with 0 or more definitions for actual menu blocks. They will all use this class, so the logic for all the menu blocks are contained in this class. But just the static metadata, the name of the menu, for instance, is different. And it is all built by the deriver. System menu. Right, so we go here. As you can see, it's a fairly simple block. It only takes the menu storage because it needs to load all the available menus. And then this is the part, this last function here, where the actual derivative definition is used. So it asks the menu storage, like, give me all the menus you have in the system. And then for every menu, it creates a new definition. And it uses the base definition, and the base definition is the one that we saw in the annotation earlier. It replaces the label by the label of the menu. It changes the ID to the name of the menu. So when a block plugin is instantiated for this, it has the ID, it can get the menu name from its own ID, and as such render the right menu. And we just make sure that we pass on the dependencies so that if we want to remove the menu, which is configuration, we can't do it if it's used by a block. To make sure that the block doesn't break when you accidentally delete menu, because you can't accidentally delete the menu. So you need a little glue class like this to expand one plugin definition into multiple. There are a couple of different ones. Let me, so deriver base, deriver interface. So let's see. So these are all plugin types for which we have derivatives. You see here local tasks, which are tabs, basically. We see field items. This is plugin selector. This is the one from the plugin module, because this is the one that provides a field widget for every plugin selector there is. And as you can see here, we get the plugin selector manager, which does the discovery and the factory. We ask, give me all the definitions of all the plugin selectors that you have in the system. And for every one, it builds a new field widget plugin. So we have, by default, 2 plugin selectors. We have 1 field widget class for this. But this glue code, this deriver, expands that 1 field widget into 2 field widgets, 1 for each of the plugin selectors in the system. All right. It's never been easier to extend Drupal in a more consistent way. We've come very, very far. Once you know this, it's abstract. Play around with it at the sprint today or tomorrow. There are plenty of plugin issues that you can work on if you want. I'll be there to help. Once you get wrap your head around this, you can extend Drupal in many, many ways. We have more plugins now than we had in Drupal 7, and it's easier to deal with all of them. So once you know the one system, you are capable of changing Drupal's behavior or contributed modules behavior in a very, very powerful way. The plugin module is on Drupal.org. You can download it. It doesn't do anything weird on your site, so you can install it, check out what it does, check out the field types, the administrator overview. Again, this is me in case you want to stalk me. We have a few more minutes. How many? Or no?
We have about 10 minutes.
Okay. We have until the rest comes in, probably. So any questions that I can answer here on the spot. If you have anything long-term, please find me in the sprint space downstairs. Are there any questions that I can answer here for you? Yeah?
Yeah. A use case question. In Drupal 7, there's quite a few modules that create what you would call an entity, content entity in Drupal 8, which is an entity for content. And then sub-modules define a bundle for that content and then do whatever they want. Can you use a plugin as a bundle for an entity, or would you always have to create?
Yes, you can.
Okay.
Yeah.
Then you need to explain me how.
Bundles in Drupal 8 are exposed using hook entity bundle info. So basically, as long as you implement that hook, it doesn't really matter where you get your bundle information from. That's how you expose it to the system. For instance, nodes. Node types are config entities. So we read all the configuration entities and we expose them as bundles for the node entity type in hook or node entity bundle info. However, for payment, for instance, like we have different types of payments. There are payment type plugins, like for a Drupal Commerce payment type, or a payment that was made through a simple payment form called the payment form payment type. And these are plugins. So what we do in the payment module is we implement this hook, we read the definitions of all the plugin type plugins. So we ask, like, hey, plugin type, or like payment type, plugin manager, give me all your definitions. For every definition, we create a new bundle for the payment content entity type. You can do that depending on what your needs are. Sometimes you need a plugin to define your bundle. Sometimes you need a configuration entity. For blocks, we also use configuration entities to define bundles. So there are many different ways.
So, yeah. Second question: if you use a plugin that's effectively just it's not a configuration entity anymore, can you then still add fields and stuff to it?
So if you define the bundles based on the plugin of plugins, yeah, you can. So any content entity is fieldable. It doesn't matter where the bundles come from. I mean, because the moment you define the bundles, the system, like Entity API, doesn't care where the bundles come from. It just knows this is the bundle name, this is the bundle human readable label, and that's fine. And then you can still attach fields to it depending on the bundle. So in the payment module, we define the bundles based on plugins, and we also attach plugins to the payments themselves. You can even do that per bundle. It's very, very flexible. Any more questions?
Do you really need a plugin module to use plugins in Drupal?
No. You can use the plugin system in Drupal core without the plugin module. The plugin system provides a few additional tools, like the administrator overview, that are useful. And most of the code that it provides that are really, really useful has to do with writing your own code that has to be able to work with any plugin anywhere, because it abstracts out a lot of things. Like all these differences in the plugin definitions, it abstracts it out to a single plugin definition interface. The storage, the configuration schemas, it all abstracts it out, so it's all unified. So if you write code, like with the field types that we wrote that store a plugin instance of any type, only if you do that, then this provides a lot of tools. Or if you want to do the form handling, like plugin selectors. If you want to write all that form API code by hand, good luck, you're not going to like it. We spend a lot of time on it here. that's another reason why you use the plugin module. Yeah? But if you want to sprint this weekend, work on plugin issues in core, you'll use the plugin system without the plugin module, and it works perfectly fine. It depends on your use case. How much? Are we done?
If we would have time for more questions.
Okay.
If you want
Any more questions? If not, no. Let it sink in. Thank you for coming. If you like this, I do recommend you go to the sprints and you contribute to Drupal, of course. The plugin API is a wonderful thing. If you want to work on something else, that's fine too. Do come to the sprints. There are plenty of experienced people who can help you out and get started. Find an issue, guide you through all the difficult things that are unclear, and help you make your first contribution to Drupal core. As a first commit, then your code will be in the code base. Thank you for coming. Enjoy the rest of the conference, and hit me up if you have any more questions. Thank you.